Good morning, everyone. Dan here for GE Inspection Technologies, and today I'd like to do a quick USM Go video to answer a question that's come up a couple of times lately. Can I use my USM Go flaw detector to take thickness measurements? And the answer is absolutely yes. It's quite easy. A couple of things we want to set up. Um, A thickness measurement is generally taken on the USM Go flaw detector by measuring the sound path to an echo in one of the gates. In this case, we're going to use gate A. And the readout for sound path in gate A is SA, so sound path in A. Here, it's already one of the selected readings in a small box. Because that's mostly what we're interested in, one of the first things we're going to do is go to the back menus with a long hold on the button here, and we're going to go to the eval menu, and we're going to select our large setting over here in the corner of the eval menu. And so we'll select that parameter and we will make that SA. Okay, so now the sound path in gate A is going to be our big reading. We'll go back out to the main menu, and now we see that the sound path in gate A is our large reading. So I have a CA211 here, a simple single element probe. I have a 5-step block with steps from 0.1 inch to 0.5 inch. Okay. If I put my probe on the 0.5 inch, we see my reading is 0.523. Okay. So I know that block is actually a 1/2 inch, so why is that wrong? All right. So one of the first things we're going to look at is gate A is positioned fairly far out. And our display range, if I want to look at a thinner block later on, a 0.2 inch block, our range is inconveniently long. So we're going to go here and we're going to back down to 1 inch of range. So there's my 0.2. There's my 0.5 inch. All right. So if I want to measure thinner materials, first thing I want to do is move my A gate in to get some thinner, make it possible to look at thinner materials. So I'll go to gates, go to gate A, and I will move my gate in. And for convenience, I'm going to start my gate just outside of the ring down from my initial pulse. Okay, there's 0.2, 0.5. All right, so let's go back to home. So we'll go back to our home menu. Okay, now I have set my velocity to common velocity for steel, 0.2323. And I notice, like I say, my 1/2 inch is showing 523. That means that I have a little bit of probe delay that is adding into the sound path. So the protective face of the probe, the coupling layer, things like that are conspiring against me to make the reading thicker than it actually is. So to null that out, I'll go up here to probe delay, and I will increase probe delay until my thickness comes down to 1/2 inch. Okay, so at 0.197, 199 microseconds of probe delay, I have 1/2 inch. If I go to 0.2 inches, I'm measuring just a little bit thick. Okay, 3, 0.4, 0.5. Okay. All right. And what I would do is adjust velocity and probe delay, tweak those a little bit until my thickness readings were right on the numbers from one step to the next. Okay. Generally, when we're taking thickness measurements for many probes, it varies from probe type to probe type, but we will often use negative half-wave rectification when measuring thickness. That's just a convention. It's not necessarily a rule. Anytime we change the rectification, we're going to have to go back and adjust our delay. Okay, get our 1/2 inch, 0.2, 0.3, 0.4. Now, the process of adjusting probe delay and velocity till we get calibrated on 2 thickness points, that's a little bit inconvenient. So we've provided, and it can also be a time-consuming thing to do, so we provided an AutoCal feature. If you look, there's an AutoCal menu. So if I go up on AutoCal, it's going to ask me for 2 reference thickness points. We're going to do a 2-point thickness calibration. We're going to give it 2 reference points. So I have my block here. I'm going to tell it that my thin reference is 0.2 inch, my thick reference is 0.5 inch. So SREF1 is my thin. I'll adjust that to be 0.2. SREF2 is my thick. I'm going to adjust that to 0.5. And I've already positioned my gate A start to a convenient place. There's my 0.2 step. There's my 0.5 step. So I have a nice long gate. It started in early enough that it's going to see the echoes from both of those steps. Now if I go down in this menu to record, I go right. It says SREF1, so I put it on the thin. Click right. Now it's saying SREF2, and you noticed it popped back up to the top of the menu. So if I needed to move my gate to pick up that 1/2 inch step, I'm already positioned to be able to easily move the gate. In this case, I don't need to move it. There's nothing to interfere. So I come back down to record. I'm on my 1/2 inch block. I go right again. It says AutoCal complete, 0.2341 inches per microsecond. And it told me what the probe delay was too. It went away quick enough that, but if we go back, probe delay is 0.323, 0.2341 inches per microsecond. Now if I go back to 0.2 step, I'm right on the numbers. 0.20, 0.300, 0.400, 0.500. So that's the auto calibration process. Again, we go to the AutoCal menu, we go up 1 click, we have our SREF1 and SREF2, the thin block and the thick block programmed in. I go to record, right one, it says SREF1, go to my thin block, okay, for SREF2, go to my thick block, and it automatically calculates the velocity and the probe delay required to take our reading. Okay, so that is how auto calibration works. Okay, yeah, if I get down to the 0.1 step, we notice I'm off a little bit. That's because my gate is starting too late. Okay, so I may have to go to my A gate, move the gate start in a little bit. We just want to make sure it stays out of the ring down from the initial pulse. But there's my start, 0.1 inch, 0.2, 0.4, 0.5. So again, SA, SAM alpha, Sierra alpha, is the sound path in gate A. That's the measurement we want to use. We want to set up gate A to be broken by the back wall echo. And this technique works with a single or a dual probe. You'll just have to set up for that single or dual mode in your receiver menu. But again, once you've selected sound path in A for your measurement, that's going to be your thickness measurement. And you can calibrate probe delay and velocity either manually or using the AutoCal feature. So again, I'm Dan Groninger for GE Inspection Technologies. Thank you very much for joining me.